Welcome back, guys. In our last video, remember we talked about a little bit about Avogadro's number and Amadeo Avogadro, and in this next video we're going to be continuing to talk about moles and conversions between grams and moles and formula units. I have an example here. We calculate the number of hydrogen atoms in 0.350 moles of glucose. Glucose, again, is blood sugar. It is what is broken down in the process of cellular respiration. Okay, so what we're going to do is, basically, this is a dimensional analyzing problem. We're going to be taking the number of moles that we have, and we're going to be converting it into hydrogen atoms. So let's take 0.350 moles. And remember, guys, make sure that you keep your units. It's going to be very helpful in the housekeeping. Now, we're going to multiply that. And remember, our goal is to end up with hydrogen atoms. So the first thing that we want to do is get rid of moles. So we know that our conversion factor is 6.022 times 10 to the 23rd molecules of C6H12O6 times over 1 mole. That is very important because now this will cancel with this. Now, we have molecules of C6H12O6. So what we can do now is we can say in 1 molecule of C6H12O6 there are 12 hydrogen atoms. So in order to cancel out molecules, we'll say 1 molecule of C6H12O6. We have 12 hydrogen atoms. Again, if you're dimensionally analyzing correctly, this will cancel with this. So now, we can check to make sure that we're at the unit that we want. We want the number of hydrogen atoms. We went from moles, but we canceled out moles with molecules. Then we went to atoms by converting the number of atoms from molecules. Okay? So all we have to do now is multiply through. When you plug everything through, you get 2.529 times 10 to the 24th power. And if you think about it, guys, that makes sense because that's a lot of atoms. And the reason that is although 0.35 moles doesn't seem like a lot, when you take Avogadro's number and figure out the number of atoms, you're going to get a very large number. Okay? Let's do another example. Okay. So I wanted to have you calculate calculate the number of CaCO3 molecules from a 2.15 gram sample of it. Okay? Again, what we want to do is we want to go 2 molecules, but we have grams. Now, we learned in our last video how to convert from grams to moles, and that's going to be very helpful for us here. So we'll take 0.215 grams. Again, guys, keep your units. Now, we talked last video about how in order to cancel out with grams, we can say that 1 mole of calcium carbonate is equal to its molar mass. And the molar mass of calcium carbonate is 100.05. Okay? Now, this is grams per mole. So if you had moles in the denominator, because it's a division quotient in your denominator, 1 mole would reciprocate to the top. Okay. So let's convert here. We have grams and grams, which will cancel. So now we have moles. Now we want to go to molecules. So what we'll do here is we'll take 6.022 times 10 to the 23rd molecules of calcium carbonate, okay, over 1 mole of calcium carbonate. Here's where you can do your cancellations. 1 mole of calcium carbonate, 1 mole of calcium carbonate. Okay? Again, guys, this is where your units come in handy. They're going to cancel out, and you'll end up with the unit you want when you dimensionally analyze. Now, carrying your calculation through, I'm going to take 0.215, multiply it, or divide it by 100.05. So that gives us 0.0214 moles, which makes a lot of sense because you have a very small sample. And then we're going to multiply it by Avogadro's number, which is 6.022 times 10 to the 23rd. And we get 1.29 times 10 to the 21 CaCO3 molecules. Okay. Now again, this is how we can check to make sure that we did this correctly. We started out with a sample of calcium carbonate. We can say that it was chalk. To convert to moles, we divided it by its molar mass. Okay, if we were going from moles to grams, we would be multiplying by the molar mass. But we're going from grams to moles, so we divide. It cancels out grams. Now after converting through that, we have moles. To get rid of moles and go to molecules, we have our conversion factor that in 1 mole of calcium carbonate is equal to 6.022 times 10 to the 23rd molecules of calcium carbonate. Okay, and that's what gives us our final answer after plugging and chugging of 1.29 times 10 to the 23rd. Okay, if you guys have any questions or requests for examples like this, please do not hesitate to contact me. I'll be doing some more examples. Okay, and then again, if you guys have any requests or questions or concerns, please let me know, and I hope to see you guys again soon. Thanks for watching. Bye.